Hello, class. Today's lesson is about the inverse functions for the trig functions. So we're going to start with the sine. And if we look at this display here, currently the only thing that's showing up is y equals sine x. So we know if we don't modify the sign that 0, 0 begins a cycle, and then the cycle ends at 2 pi. Okay, and it peaks out here at pi over 2. So for x, pi over 2 is where we get the 1. And then we get another 0 here at pi coming back down through there. So x is pi there. And then this is 3 pi over 2, where it bottoms out, and then it goes up to 2 pi again, and then begins the cycle over again. So I want to take a minute to talk about inverse functions in general. So if you remember an inverse function, it should reflect itself about a line y equal x. Okay, so I'm going to turn on the line y equal x. Okay, and in order to create the inverse, remember that in an inverse, everything that was x becomes y, and everything that was y becomes x. Okay, so for instance, let's go to this pi over 2. So when x is pi over 2, we know that y is equal to 1. So that's the ordered pair that would be in the sine, y equals sine of x. So if we create the inverse function, we should find that 1 pi over 2 takes the place. All right, so I'm going to go ahead and turn on the inverse function. So notice that I've changed the place of x and y. Remember, that's how you create an inverse, is you swap the locations for x and y, and then y takes on the x role and x takes on the old y role. So, and it's a reflection about the line y equals x. So if I turn everything else off and we just see the inverse function, we have a problem. I called it an inverse function, but a function has to pass the vertical line test. And so if I run a vertical line through this inverse of the sine, it's going to touch it in many places, infinite number of places. So we fix that by restricting the domain so that the domain is only going to go between these 2 points. Okay, so if I start the inverse function, and remember now that y is the x part and x is the y part. So now we're going to start at an x of -1. So at x of -1, that's where we get negative pi over 2. And at x of 1, we get positive pi over 2. So if I was able to just restrict the domain to go between -1 and 1, then my range would be restricted to negative pi over 2 and up here, positive pi over 2. Okay, so this is how we refer to the inverse function. Now I'm going to turn off the entire, so this relation is not a function. I'm going to turn it off, and if we actually want the inverse sine, it'll restrict the domain for us. Okay, so we're going to annotate the inverse sine as y equals sine inverse. So this looks like a to the power of -1. That's just the signal for an inverse function. All right, so now just as an example, I could say, find me the angle whose sine is -1. Okay, so if I plug a -1 into the inverse sine, I get back negative pi over 2. Okay, so in this case, y is equal to negative pi over 2. Okay, same goes if we look at this 0, find me the angle whose sine is 0, and then the angle whose sine is 0 is 0 radians. Okay, now I've brought up the unit circle because this is helpful not just with finding the sine of an angle, but it's also helpful for finding the inverse sines. So notice that our x starts at -1 and it ends at +1. So that's the domain for the inverse sine. And then the range is from -π/2 up to π/2. So if we look at the unit circle, we're interpreting only this location here, from -π/2 up to π/2. We can call 3π/2 because if the coterminal negative angle with 3π/2 is -π/2. Okay, and so using our number line, that's a better way to address it. We wouldn't want to call this to the left of the 0, the origin, a positive 3π/2. So we're going to go from -π/2 up to π/2. Now remember, if I asked for the sine, so I said, give me the sine of, let's say, π/4. Okay, so remember the sine is the y coordinate. So the sine of π/4 is going to be square root of 2 over 2. But if I ask for the inverse sine, if I said, give me the angle who has the sine of the square root of 2 over 2, so the answer to an inverse sine is an angle, so that would be π/4. Okay, let's take a look at another one. So what if I asked you for the inverse sine of a square root of 3 over 2? Okay, the sine of which angle is a square root of 3 over 2? Well, that would be π/3 or 60 degrees. Okay, so here's the summary here of the inverse sine of x. Here's its graph, and the domain begins at -1, ends at +1, and the range begins at -π/2 and ends at π/2. Let's take a look and do the same thing for the cosine. Okay, so on this tab, I've got the cosine showing y is equal to cosine of x, so it's got that sinusoidal pattern. Remember, its inverse should reflect over y equals x, so let's put that line in there. And if I exchange the x's with y's and the y's with x's, I should get the inverse relation. And I do, but again, it's not a function because the vertical line passes through it more than once. So we can restrict the domain and change it to just the inverse cosine. And now if I take away that, I can see that the inverse cosine is going to start here at -1, and then it's going to end over here at +1. So if I show these endpoints, we can see the domain and range as well. So let's take a look at the unit circle. And now we're talking about going from 0 through pi. So if we were going to show that, this represents the portion of the unit circle that's within the domain and range of the inverse cosine. Okay, so we can get everything we need from just this one portion of the cycle in each case. Okay, so let's work within this domain and range to find some inverse cosines. So let's say we ask for the inverse cosine of negative square root of 3 over 2. Okay, and if we're in the proper domain and range, we should only be able to find one such result. So positive square root of 3 over 2 would have been pi over 6, but since it's negative square root of 3 over 2, we're over on this side of the, and the angle is 5 pi over 6, or 150 degrees. And if we asked for a cosine inverse cosine of negative 1/2. Okay, so my cosine, the angle whose cosine is negative 1/2 is 2 pi over 3, or 120 degrees. Okay, here we're looking at the tangent. And remember that the tangent is undefined whenever the x-coordinate is 0 on the unit circle, because the tangent is built from y over x, or sine over cosine. So whenever the denominator is 0, we hit an asymptote, and that's why these keep shooting up. Jump over the asymptote and start anew. And if we put, for instance, asymptote lines here between negative pi over 2 and pi over 2, and we can just capture one of these cycles. And so, as before, I'll drop the line y equal x, and if we reflect that one cycle about y equal x, then we get this purple line. So I'm going to turn everything else off. Okay, and we can see now that if my only graph is showing is the inverse, so here's a look at the inverse tangent. So as we can see on the inverse tangent, x goes from negative infinity to positive infinity, but y is limited between negative pi over 2 and pi over 2. So if I make asymptote lines at, change this to y, okay, that's going to show us the lower bound of this, the asymptote in the y direction. We're coming down towards negative pi over 2 and reaching up towards pi over 2. Okay, so that's going to be the range of the inverse tangent, negative pi over 2 to pi over 2. And it is important to mention that for the range, negative pi over 2 itself is not part of it, nor is pi over 2. So it has to be strictly between negative pi over 2 and pi over 2. But the domain in this case is negative infinity to infinity. Okay, so let's focus in on this here. I know that if we ask for the tangent of pi over 4, remember that's y over x, so this number divided by the same number, we know the tangent of pi over 4 to be 1. So if I ask in the other direction, I said the inverse tangent of 1, I can see that if I take y over x, I get a 1 here, in between negative pi over 2 and pi over 2. So I can see that that is pi over 4. And remember, our range is restricted to negative pi over 2 to pi over 2. So we're always going to consult the tangent that lands in this realm here, no matter where we get it. So for instance, let's ask for the inverse tangent of negative 1. Okay, so there's two places where I could get a -1. One is here at 3 pi over 4. If I divide this number by its opposite, I get a -1. But it happens over here as well. But since our range is limited from negative, because we're only using this portion that we reflected, our range is limited from -pi/2 to pi/2. Remember, this is -pi/2. Okay, so our range comes from this. So we're going to say it's this one. Okay, and we're not going to say 7 pi/4. We're going to say -pi/4. Okay, and just one more example. Let's come up here and let's take the square root of 3 over 2 and divide it by 1/2. Okay, so that's this one, right? Well, that'll simplify to the square root of 3. So if we ask for the inverse tangent of the square root of 3, it's going to be the pi/3 angle.